this is going to be a pretty short post. I don't really have much of a way for you as far as manufacturing or hands-on sort of things. This is mainly an introduction to my next project. If you know me from my website days, that is homebrewprocessors.net, which is mainly, you got here from a link that I posted on there. Then you know that I have a tendency to do things incrementally in stepwise format. That is, I first do an introduction where I lay out basic dots, and then it progresses through different phases of construction. Admittedly, I take way too long of these, so that's something I'm going to be working on. The next project on the table is a CNC mill, mainly because of, well, I mean, with a CNC mill and, you know, a bunch of ingenuity, you can essentially manufacture 90% of every part out there. So this is a major goal of mine, to build one that I can use to manufacture and actually be free form, rather than having to use drill presses and bandsaws and manual sort of machining tools to get a task done. I have a few interesting things planned from the get-go for this, and that are centered around the idea of machining 80% AR-15 receivers, if that's your kind of thing. When building a CNC mill, there are numerous things to consider. First being the topography of it, topography. That is, how are you going to construct the machine? And obviously there's an infinite number of different ways you can do this, depending on where you want to put each bolt. But there are two major different designs that vary based on how the workpiece, the part to be machined, moves in relation to the spindle, the actual cutting head. You can either move the spindle, or you can move the table that the workpiece is fixed to. Essentially, this changes which part is actually translating. Moving table mills, where the table is the part that translates, are more suited for things like converting drill presses and stuff like that. Ideally, they have better accuracy, somewhat, because of various things that my head doesn't want to describe now because I'm in front of a camera. I'll think of a way to describe it. I'll put it in the description, so check that. Or I'll just do a part 2 to this video. Yeah. And then there's obviously the moving spindle, where the spindle goes through the full axis of rotation. And then there's various hybrids of each. Obviously, there's 3, 4, and 5 axis machines. We're going to be building a 3-axis machine. 4 and 5 axis machines are used when you need different degrees of rotation around your part. For example, milling helical grooves into a round bar piece of stock would typically involve a 4-axis machine. And then most machining of stuff like turbine blades and rotors is typically done on a 5-axis machine, because it allows 2 extra degrees of freedom. I mean, you can do a turbine blade on a 3-axis machine. It's going to involve a lot of manual taking it off and spinning it. 5-axis machines are used to automate the process. So obviously those machines increase in 1 or 2 levels of complexity, not only in the actual layout, how you're going to mechanically arrange the systems, but then in, well, how you're going to control it, the software. Obviously, if you're trying to write hand G code, you're going to have a hard time. The main reason I'm doing this video now, even though the reflow of the project isn't really bearing fruit yet, is because, I mean, I want to turn this channel into a sort of manufacturing technology sort of, half video blog of my projects, sort of a showcase. But I also want to do things that are actually applicable to machining. And there's no doubt you're not going to be making a whole hell of a lot of a reflow oven. You could try. I don't recommend it. So, I should be starting on actually building a CNC mill around mid-November. I'm going to wait until I get my new iPhone. Yawn. Because of the fact that I can use its camera to actually get more in-depth and close videos rather than having to figure out a way to generate a tripod on the workbench. Also around that time, I'm also going to be doing the actual videos on reflowing parts. Working with surface mount devices. So stay tuned around there, folks. If you have any questions, put them in the comments. Read the description, because usually I like to put extra talks that I couldn't think of in the description. And subscribe if you want to see more. Alright, thanks guys.